So thank you. It's a great honor to speak today. I wanted to start by acknowledging Dr. Choi. When he introduces himself, he always says CS Choi. And you should know that CS stands for customer satisfaction. Now we know that at IDT because Dongbu consistently proves themselves to be our favorite wafer fab supplier. And it really is the result of efforts that Dr. Choi and his team bring to us all the time, not just in the development of the advanced technology, but the delivery of it quickly that allows us to be successful and enable our customers' success. So customer satisfaction, Choi, thank you for having me. It's also really easy for me to come and be excited about this because this is a very important market that I'll talk about, important to customers. It's certainly important to a big ecosystem that involves Korea very much. Think about the impact in smartphones alone, and you know that there are really important, significant worldwide players such as Samsung and LG that are an important part of this ecosystem. And also, it's extraordinarily important about IDT, so we're honored to come talk about it. Now, before I jump right into the wireless charging presentation, I do want to put a little perspective around IDT just so you know a little bit more about us. And I will try. There we go. And then I will go on and talk about wireless charging more specifically. So IDT is basically a $500 million a year semiconductor company. Not especially big, but bigger than a lot of others. We happen to be in a very good position right now with over $300 million in cash on our balance sheets. We have returned to significant profitability, and we're on a journey to do even better in the near term as well. We have a worldwide presence headquartered in San Jose with a broad array of products, a very mixed signal DNA inside of this company with some distinct changes over the last few years. How we focus, we really see that there have been three enormous shifts that impact the world of electronics over the last few years and are clear to continue to impact it moving forward. That is the trend of mobility, or sometimes I talk about personalization, the 4G infrastructure, and the impact of cloud computing. Now, for all of these marketplaces, there are important technology transitions that take place, whether it's trying to have a product that has better battery life and mobility, the drive for shrinking form factors, the ever-increasing demand for lower cost. In the 4G LG world, it's really all about speed, a distinctly higher speed experience for the user, really interesting battles with, say, the Apple operating system.
Because of the how late this mic doesn't work. So
okay. All right, I just got told that that mic wasn't working, so I can be pretty loud. I'll try to be a little softer maybe now that I have a microphone. And then in the cloud computing, you have some really important developments. Intel tends to be the big dominant force in that space, but you also see ARM processors now becoming an important play even in the server world. And for us, some very powerful trends in memory interface that we're working on. All of these really, interestingly, represent performance bottlenecks or challenges that come about at the interfaces, and that's what IDT is really good at. We actually have three very distinct focuses that you should think about when you think about us: interface and connectivity, analog and power, which we'll talk about more distinctly one segment in that today, and timing and synchronization, with a broad product portfolio that includes memory interfaces devices, the serial rapid I/O products that go in the heart of the digital line card on a 4G base station, power management products. We have solutions in PMEX and, of course, wireless charging that we'll talk about. And the great secret strength that people seem to forget about IDT often is our largest business, and that is timing. And we make everything from relatively simple clocks to complicated clock distribution networks to really cool frequency generators that can be used in the most advanced communication systems because we can do lower jitter with absolutely no phase noise, better products than anybody in the industry. It's a great product portfolio. But the one area that's been new over the last few years for IDT, and we're starting to get some real traction on, is power management. And specifically today, we'll talk about wireless charging and all which that implies. I think it's time to cut the cord. You know, this is a mess. And it's interesting for us that live our lives in the world of mobile electronics that the last cords that we seem to accept are all these cords that connect our power. If you think about our tablets, our cell phones today, we don't connect them to a wire anymore for anything. We get our software updates wirelessly, right? We communicate with the computer wirelessly. We download our music wirelessly. We download the pictures wirelessly. And for some reason, we seem willing to accept that we can be tethered to power supply cords. And really, when you think about taking all of your electronics and making it personal and mobile, it's time to cut the cords. And that technology is now available, and we're on the verge of watching it explode. It's really all about this personalization becoming mobile. So whether you use a device to watch a video clip of last night's baseball game or soccer match, or you download pictures, or you listen to your music, or you check your email, or you send a text, or you send a picture text, or you play a game, or goodness gracious, maybe you even make a phone call, you are using that device all the time. And the last thing that a service provider who's trying to send more and more packets over the network to you, or a developer of an application, whether that's a navigation system, a social networking opportunity, a game, the last thing they want is for you not to use it because you don't have power. But the more we use these devices, the more power they draw and more likely we're to run out. So the challenge becomes, how do we solve that? It's clear that the idea of being able to easily, in lots of places, without having to connect up, charge our devices, whatever that may be, would offer really, really distinct benefit to the user. So that makes it a great market. Real user benefit. Okay? It's all about convenience. It's about being able to charge in lots of different spaces at lots of different times. And there are all kinds of applications here. We'll talk about the dominance of smartphones, of course. But it's more than that. It could be your smartphone. It could be a digital camera. It could be a game player like you have there. It could be your wireless headset. It could be game consoles. It could be wearable devices like the watches that are starting to have some traction. Certainly notebook computers are possible. It could be in your car. The wireless infrastructure could be at your Starbucks store. It could be in the airplane. It could be at the airport. It could be at the little cafe. Okay? It's all about convenience. It could be, you could have wireless charging in your power tools. But there's no question the market will be big, which we think about all this convenience, and now we say, oh my gosh, real user benefit and a large market, that's going to be terrific to be participating in. In the short term, there's no question that tablets and mobile devices, smartphones, will dominate the volume. That's not all there will be. Surely Google will soon wirelessly charge their goggles. The wearable watches are already done wirelessly, actually, and that'll be even more so. But for quite some period of time, you can expect that smartphones and tablets will dominate where the volume comes. That actually happens to be really good for Korea because of the power of Samsung and LG alone in that space. So this is going to be a very interesting market opportunity. And because of the technologies that Dongbu has and their relevance in solving these problems, which we'll talk about a little bit more, also says that's going to be good for Korea. How many? I don't know. But by next year, by calendar 14, you're talking about over 1 billion smartphones. This is just smartphones. It's not tablets. It's not low-end phones. Just the ones that are running lots and lots of applications. Over 1 billion units a year. That's really big. That is a big market. There are not many things that are measured with a B in front of them. And that's just the cell phone piece. What percentage of them will include wireless charging? Not that many so far, but it will explode. I happen to have a personal belief that in just a few years, you will look at wireless charging the same way you do Bluetooth or Wi-Fi on your devices. I can't imagine a high-end phone being offered without it. It's just a little more complicated than some of those in that it takes an infrastructure that we'll talk about in a few minutes, and there are some developments that probably impact the speed, maybe slow it down a little bit as well. But at the end of the day, between transmitters and receivers, billions and billions of units. So we have a market with great user benefit, a market that will be very big, that makes it interesting, The third dimension that's really cool, especially if we're at a technical conference, is that it is a technically challenging problem that we're trying to solve. You're talking about a true mixed signal application. You're talking about all different kinds of ranges, all different kinds of powers and voltage requirements. And you're talking about different types of wireless technology that will dominate the standards. There is no single standard. In fact, some people are so big, think of the Cupertino-based outfit or the Big S in Korea, if they wanted to not follow a standard, the truth is they have enough power that they could probably do that. So it's very technically challenging as well. How so? Think about what has to be included in the way we do wireless charging or wireless power. If you're going to develop a solution, transmit or receive side, you're going to have to be capable of doing power management, of course, because we're talking about wireless charging. You're going to have some intelligence. You're going to have to be able to deal with RF. You have to be a magnetics expert. You have to have communication links back and forth between the two. You have to deal with EMI because you're blasting you're not really blasting it, but you're modulating an antenna of sorts. That coil is really an antenna. So we're going to increase those challenges. And we're going to have to do it with some closed loop control. It's not for the faint of heart. It's not a big chip, but it's a great chip from a complex system architecture. And it takes complex processes to pull it off. RF, big DMOS type, power FETs on there to get the power part right, digital electronics. So it's pretty cool. If you're an engineer, it's an exciting technical challenge as well. So to me, those three dimensions, real user benefit, a very big market, and technically challenging, make it a very stimulating place to be. If you're a marketer, you can get excited about it. If you're a technologist, you can get excited about it. If you're a user that wants to be able to carry their personal electronics, their personal electronic experience with them all the time, you're excited about it because of the user benefit. Let's keep talking about some of the technical challenges for a second. There are some standards at work here. There basically are two dominant approaches that are used when we charge wirelessly. One is referred to as magnetic induction. Basically, we lay the device right on a very specific mat. We'll talk a little bit more about that, but pretty straightforward. Lay it down on the mat. The other is, let me go back to it. The other is referred to as magnetic resonance. And this is proximity-based, and rather than talk about it, let me show you a couple of video clips, if I can, that'll show you what you can expect with this approach. Maybe. Can't find them. If not, I can song and dance. We have a piano up here. I could go talk about magnetic resonance. Okay, it's all right. We can't find them. Do you think they're somewhere else? Sue's going to go look. But in the meantime, rather than get you all excited about some propaganda from Intel and Qualcomm, we have some really cool little videos. Okay, thanks. So we'll jump back in here. So two basic approaches. Magnetic induction, lay it right down on a mat. Magnetic resonant, we just have to be close. We'll talk a little bit more about that. What's the best solution? I don't know. Even Senior Vice President Armin Nagami does not know.
Actually,
okay?
That was my question.
Okay. And not only that, just so we're clear about IDT, we don't care which one is better, which one wins. We look at this like Switzerland does as a country. They try to avoid conflicts, they stay neutral. Our position is to be neutral, but we are developing, and I'll talk about it, we're developing very effective solutions for both. But our view is the market will decide this, not the semiconductor industry. And even Dongbu, with all their power as a wafer fab, as a creator of great technology, it won't be them. It'll really be the market that decides. Okay, so let's talk about them a little bit. With magnetic induction, the real key here is that you're talking about containing the field between these coils and needing to have nice, tight coil alignment. And the upside is that you're really not projecting that magnetic field out beyond sort of the space of the charging mat or whatever it might be, whatever sort of physical device you're using the field is contained within that. Some advantages to that for sure, some requirements with it. And in magnetic resonant, we actually design that magnetic coil as an antenna, and it projects the field outward. So you just have to be close to it. A different kind of a challenge, one not necessarily better than the other. Advantages probably to both. But you know, this does give some loose coupling. You have a little more freedom as to where the device might go. Now specifically, we go back to this inductive approach. You really are trying to align these coils so that they can be inductively coupled. And it's really the transmit coil that stimulates the receive coil. Okay, that probably makes pretty straightforward sense. And again, we contain that field in a relatively small physical space between the coils. And we can make that coupling better, sort of like antenna design where we match impedances, right? Very similar in the world of magnetics here in the context of, let me go back because I want to say something about matching up those coils. Matching coil sizes, keeping the physics of how they're aligned close, that improves the performance there pretty nicely. Now what it does require is that we get those close, and there are a couple of ways to do it. You can use magnets to pull the device right over the correct coil. You can move the coil underneath it inside of the charging pad, or you can free position it on a big array. We've yet to see a charging platform that has quite that many coils in it. I think generally what you see is 3. Armin, is that right? So 3. I think maybe somebody did it with 5, but we haven't seen the 10 yet, but it makes for a pretty picture. But the idea is there. More coils create more spatial freedom with a requirement that still the coil's got to be right on top. So it gives you that illusion of greater spatial freedom. It's not really an illusion. You do have more spatial freedom, but you do it by applying more magnetic field inside of the coils. Now there are standardization efforts that are really important in both of these. In magnetic induction, there's WPC and PMA, the Wireless Power Consortium, and they drive a standard known as CHI, okay? And then the Power Matters Alliance. This is where most of the early work exists in magnetic induction solutions. There are many, 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 many players that are active in this. There's also standards activity in the magnetic resonant field with a consortium called the Alliance for Wireless Power, or sometimes known as A4WP. Intel and Qualcomm have been very active at leading that activity. IDT participates in all 3 of these standardization efforts. We have seats on all 3 groups. We're a very credible participant in all of these. Qualcomm, interestingly, just announced that they're also participating in WPC around the CHI standard. This is not them giving up on magnetic resonant. If you read it that way, that's a mistake. I think it's probably Qualcomm saying, we would like to influence what WPC does around magnetic resonant to be consistent with what we already know and do. So you can certainly expect that even the standard groups that have started with magnetic inductance will also look at magnetic resonance as well, and that's why you see them playing that game. We're very honored at IDT that's in the public domain that both Intel and Qualcomm are working with us. So it's a very nice position to be in and gives us a unique view on this marketplace. Now, for IDT, that's really important, that we are developing solutions for both magnetic inductance and magnetic resonance. We have multi-mode products that are either, we can be WPC, CHI compliant, or PMA compliant, or both. We'll talk about that. We have the widest portfolio of transmitter solutions in the market. Our receivers have the shortest charging times. We're in a very good position, and I'll talk more about our dual mode support in a little bit. And again, in magnetic resonance, we're active in this group as well with partnerships with both Intel and Qualcomm. Regardless of how you're approaching this, the transmit and the receive side, you're going to have power conversion to begin with to get it from magnetic to electrical. You're going to have to be able to adapt to the power needs of the device, provide some control, and communicate back and forth. So it's a pretty complicated partnership between the transmit and the receive side that takes place. Let's talk about some of the challenges then that exist inside of this marketplace. Well, Is it going to be magnetic induction or magnetic resonance? When there are two standards, sometimes things evolve a bit more slowly. But we can't impact that. There are at least two big technical approaches to this. In magnetic induction, there are two standards bodies working. The WPC or the Chi standard and Power Matters Alliance. Ooh, that makes it tough. And you have another challenge in that the users of this technology, the people who choose to insert it into their tablet or their notebook or their smartphone or their headset or their game console, they want differentiation. You know, standards are great for some respects, but sometimes they take a lot of differentiation and control away from the designers. They don't necessarily like that. So there's some pretty tough challenges. So what do we do about that at IDT, if you allow me a bit of a commercial? The first thing is we have a true dual mode receiver, the 9021, okay? And basically it automatically switches, this is for magnetic induction, it automatically switches between the WPC or the PMA standard. Chip is smart enough to know what kind of a mat you've laid it down on. The great thing for a user is if you're trying to make a decision on which technology to insert in your platform, let's say that you knew that you were going to go into markets where you only wanted to address the PMA standard. You could lay out your board, change your discrete componentry, but with one layout you could enable it for just WPC, you could enable it for just PMA, or you could completely configure it, same layout, just different selection of discretes. You can have a device that can handle either one. Pretty slick solution. And we're the only one who can certify to both standards right now. Will other suppliers try to do this? Of course. Have others tried already? Of course. Have they failed already? Yes. Very nice. So we like that. Competition is good. It's even better when the competition fails. So I don't care about them. I care about us. But we're in a really good position. Now there's some great, this is a very complicated chip, and there's some great stuff on it. Some things that really make it unique. We have better efficiency in our rectifiers. We've got a secure two-way communication capability. We include I2C as a methodology for communicating back to the apps processor inside of the smartphone as well. We have a proprietary back-channel communication capability. We have the best foreign object detection. You know, if you lay a quarter or something metal on the mat, you don't want it to start charging, you know, sending charge, turning things on. And we have solutions where we have a full microcontroller in there that allows great customization, or we also do solutions where there's just a state machine. We can simplify it if you don't need that capability. But these are some pretty unique capabilities that IDT brings to the game that others haven't quite added yet to their performance level. So, how are we solving this, magnetic induction or magnetic resonance? IDT offers both solutions. Two standards. We support both standards. In fact, we have the first and only chip so far that can meet and be certified to both standards and makes all of that decision making itself. You don't have to worry about, you know, where else the smarts are. We put it right in the chip ourselves if you want to be able to claim compatibility with both of these magnetic induction standards. How do we help system designers? The powerful way to do it is put a microcontroller on there. Costs more, of course. You will have to pay a little more for that solution, but you will get great value by doing that as well. And we have some proprietary back-channel communications capabilities that can do some cool things as well. Just get a little creative. Even if we have the best solutions, this is still a complicated problem because you have an ecosystem at work. It won't be IDT that gets to determine the end game here. It starts with these standards, okay? And the standards are evolving and working with telecom carriers. These are the dominant players that can decide how quickly does this get implemented. AT&T's already told its partners mandatory for 2014. Now, mandatory to them isn't quite mandatory the way if I told Armin something was mandatory, he might be quicker to respond. But, you know, if Apple doesn't have a solution for this immediately, AT&T is still going to sell their phones. Okay, we know that. But if HTC or Kyocera want to penetrate, I think they're going to have a wireless charging solution for that. So these carriers are going to be very influential. That, interestingly enough, as you would expect, is exactly who the handset makers respond to. Okay, they don't respond to the semi guys, they respond to the person who's paying them for their handsets. And ultimately in this ecosystem, you have a bunch of accessory type people, a bunch of OEMs and ODMs that are going to be playing in this as well, whether it's as an accessory, a charging mat, getting it inserted in big mats that go into McDonald's or Starbucks or inside of furniture or, you know, in your bedside lamp, whatever. There'll be a lot of people that play in that game. And for us, at the middle of it all, is IDT and our solutions. So when I think about this market, just to close again and think about the road to true mobility and personalization, this is a great market because it offers real benefits to the user. This is about not having to worry about that dreaded 20% battery life left, 10% battery life left, just when you're trying to use it as a navigation device to figure out how to get somewhere, right? It's a rapidly growing market, and it will be very, very big. And big is good. Big means there'll be money to be made. It also means there'll be a lot of competition, but that's okay. The other great thing about this is there are great technical and market challenges. Might mean that it's a little slow to evolve because of that, but it certainly makes it interesting for us. And at the end of the day, we're going to bring superior solutions to bear. So make no mistake, when it comes to wireless charging, IDT is really excited about this market, really committed to this market, and really capable of delivering the very best solutions that are out there. Thank you very much.